I wanted to put your mind to put some thoughts into your mind again around event-driven microservices that we've been talking about. And some of the concepts that I'll be talking about right now have appeared already throughout the day, right? So this could be viewed as somewhat of a summary or somewhat of a confirmation of those thoughts. Somebody asked me today, like, are these ideas that are these your own? And well, no, they're not. They're not. All the things we talk about and we believe in are not necessarily all of our own ideas. We're not an ivory tower or a group of people in an ivory tower thinking, okay, what would be the best way to build software? And then we throw all ideas down the tower to the people so that they can use it. Now, this involves a lot of interaction, a lot of discussions with people way smarter than, definitely than me. And you just combine everything and try to make some sense of it. But unfortunately, in those discussions, I also come across a lot of nonsense. And I'm trying to figure out what's the nonsense and how can we turn that around and make it into something. What can we do to get rid of that nonsense and make it more usable? So once upon a time, somewhere in your life and mine, we used to build software using a very typical layered architecture. And I came across, I used, if you've seen presentations by me, I use different images for layered architecture. And somebody used this picture, and I thought, that is ideal. It just shows let's be honest, the stupidity of this whole concept in the type of systems that we're building nowadays, right? At the time, it made sense. But put your mind at that time, and everything was different back then. This has, fortunately, nothing to do with the British Broadcast Company. Fortunately for them, right? But still, this universal architecture is universal. It is everywhere, right? There's different variations, right? There's variations with 1 box, 2 boxes, 3 boxes, 4 boxes, 5, depending on how many versions they've deployed and how many problems they've encountered, because we all know that if you have a problem, you add a layer of abstraction, and then that problem is gone. You get 5 problems in return, but that's okay. You can reduce those with another layer of abstraction, etc., etc. And we all know that software ends up as a big ball of mud. That joke has been made several times. I've even seen other people make that joke. If you don't know what I'm talking about, approach me later on. And of course, we have microservices to the rescue, right? So we stopped doing the BBC architecture, and we started doing microservices, because all the companies that were big and successful, like Netflix, Netflix is a good example. They're very successful, and they use microservices. So if we use microservices in our startup, we'll end up like Netflix, probably making movies and series and, etc. That probably won't work. But why do we care about microservices? Why is that such a big thing? Well, the whole idea is for scalability of teams, as well as other aspects of scalability, and agility, right? Having smaller components, it makes it easier to modify one of these small components. You can separate your groups of developers to focus on one of these components, and, that's great. But there's a balance, right? It's not all happy, happy, joy, joy. There's another side to the scale as well, and it adds a lot of complexity. And unless you're ready to take on that complexity, going to microservices is really a really bad idea. I've had the chance to have a conversation with one of the directors of platform, or the director at the time of platform engineering for Netflix, and I told him, "Why are you talking at conferences? What's your incentive?" And he said, "Well, we want to tell people the hell that we've gone through and are still going through to keep this microservices landscape afloat. They are building tools to keep themselves alive, to manage the chaos, literally, that they have created. And I guess that's okay. They are an organization that is very that is built to adapt themselves, and they can manage that, right? They're still doing a pretty good job of that. But the organization you work for is probably not like that. So you have to be able to take on that additional complexity. Now, this is the uniform microservices architecture, right? We take that beautiful concept of box, box, cylinder. Be careful if you watch Formula One, before they go into the pit, they always say box, box. In my mind, they say box, box, cylinder. So be careful, don't listen to this too many times. But of course, now there's boxes and boxes of, now we have boxes with boxes and boxes and cylinders that are talking to other boxes, and now we have data storage boxes, right? And there are some logic boxes, and, on the other side, there are some UI logic boxes, and of course they all have their own database because somebody said that was a good idea. Even Ben said it just now, in a completely different context, fortunately. But there's this layer you can see in many microservices implementations. You can still see those layers. Right? You still see that box, box, cylinder kind of layering in there, and that is a complete waste of effort. Because now you do have the disadvantages, but you don't get the advantages. And what it also leads to is, I'm not sure if Alberto needs to get the credits for this, but he's the one that used that term in my presence, and I really liked it. What you get is noun-driven design. And noun-driven design is a very nice concept that allows you to very efficiently and effectively build distributed big balls of mud. So if that's what you're up to, pay attention. This is how you do it. You read a document, a specification. If you find a noun, build a service for it. And all the verbs that are in the vicinity of that noun, they are operations on your service. Let me give you a few examples. Order service is a great service. It does everything related to an order, especially load, save, create, and delete. We have a customer service. Well, we all know customer service is fake. We have product service. It does all the CRUD stuff you want on products, right? That's et cetera, et cetera. Inventory service, and that's great. Now what we're doing, instead of creating a big ball of mud, we are increasing the number of deployment units, not anything else. We're keeping the same architectural principles. What do you get when you take shit and increase the number of deployment units? Lots of shit. The thing that we need to do is not increase the number of deployment units. What we need to do is increase the modularity of our system. Microservices does not make your system modular. So what you would need is some box with nice colors inside. Okay. What you need is a system that internally has a clearly visible structure. There's clearly defined components in there that communicate through ways that you have defined and that are safeguarded in some way. And we'll get to some examples later on how you can do that. And then you can increase the number of deployment units, which will eventually give you microservices that have more of a focus on behavior than state. Not the nouns are important, it's the verbs. Verb-driven design is much more, well, it's not really the answer, but it's closer to the answer than noun-driven design. Unfortunately, our environment is not ideal. The area, the environment that we need to work in, and I'm not really talking about the desk and the seat and the type of computer that you need to work on, but there's other aspects around, and they are the evil anti-modularity forces that are around at the office. They come in different shapes and forms. A very well-known one is technical debt. Technical debt is a very strong force, and it gets stronger as you go to the right, and it pushes you down, eventually decaying everything into mud. So we need to make sure that we have that uplift. But the other anti-modularity force is people in suits telling you that they want feature XYZ on date XYZ, and you better get it done. They are evil, right? So either get them out, or, thank you for the advice, Alberto, get yourself out. Go somewhere else. And that's very dangerous, but you need to make sure that you can counteract these the evil anti-modularity forces. Now, another thing we need is wax on, wax off. I did this presentation once before, and I realized that maybe I'm getting part of the old side of people. That was a pretty confronting experience. Who does not know what this is from? The young guys. All right, so this is a scene from a movie called The Karate Kid. Right? After you finish reading the book Accelerate, watch this movie. Watch this scene again and again and again and again and again and again. Now, this little kid here wants to learn karate, right? So he's like, okay, cool, come on, let's learn. But Mr. Miyagi is, no, that's not how you learn karate. First, you wax my car. He's like, why? What's the point? Oh, wax on, wax off. And that's really annoying. He wants to build microservices. I mean, learn karate, but he's doing all that stupid stuff that he doesn't want to do, and it's annoying, and he doesn't feel he's learning anything. There's a few, basically he's learning the foundations of karate while doing the wax on, wax off, right? And this represents the discipline that you need to get to learn certain techniques. Karate is one of them, microservices is another one. So if you want to build microservices, make sure you can build a decent monolith first. If you cannot build a decent monolith, you will build distributed crap. I promise. So how does that work? If you have an idea or you have this concept that you want to implement, and you think about going to microservices, probably the shortest path there leads through Death Valley. Right? This is the dangerous area where evil anti-modularity forces will force you into building a distributed big ball of mud. Instead, build a monolith first, and as your application evolves, and as your team evolves, and the maturity of the team evolves, you will find that certain components may need to be extracted from that monolith, or new components need to be built separately from that monolith because there are non-functional requirements telling you so. The requirements are never functional, they're always non-functional. They may be the team is growing too large, we need to separate the code bases and have different deployment cycles. It might be that that blue component eats up so much memory that it restrains the other components from working normally. It could be anything. And as you evolve, you can extract some more. And maybe, if you can wax a car really, really well, you can even go serverless. And the thing that makes that possible, and it's a term that I'm happy has appeared a couple of times already today, is location transparency. It's the fact that these components inside the monolith are not aware that the component they communicate with is also in the monolith. Because if it were aware of that, you wouldn't be able to extract it. You would have to change a lot of code inside to make it work. If you have location transparency, you have the ability to use it when you need it. And events are a very nice way to reach that location transparency, right? You can emit an event, and it doesn't matter where it ends up. That's fantastic. So if a service does something, instead of calling service C, you can use an event. And that event is then published to service B, C, and D. That removes a dependency from service A to all the other services. That's very nice. It's very powerful concepts that we can use. So let's event all the things. That's what we really like, right? We find a really good, we as a larger community of developers around the world, when we see a nice shiny tool, we use that tool for everything. So we event all the things. That's great. Now that's called Maslow's hammer, right? If all you have is a hammer, everything looks like a nail. I don't really like that term. In the UK, they call it a Birmingham screwdriver. If all you have is a screw, well, any problem you can fix with a screwdriver, basically. I don't like that either. It sounds like a cocktail, and a pretty good one as well. Like, hey, bartender, can I have a Birmingham screwdriver? I know, I'll have a good night. But there's another term, fortunately, that I like much more, is Maslow Syndrome. And it sounds like a disease. It's much better. It has this inherent negativity in it, which I like in this case. Because not everything is an event. Right? Events are a big thing, but they're not everything. But there are situations where they are useful. There's different ways of using events to your advantage. And there's different patterns defined, and one is event notification. It's just to nudge another system, like, hey, there's some work for you to do, and it will wake up and start working. That's very nice in some situations. Then there's event-carried state transfer. If you're used to using Axon, or if you're used to Axon, this is the approach Axon takes. There are events describing themselves what's done, right? What's happened just now. And there's another thing, that's event sourcing. And that's the whole level of being event-driven. Unfortunately, there's a lot of content out there using technology XYZ, you can do event sourcing. And then you read, and like, no, that's not event sourcing. That's just moving an event from point A to point B. Event sourcing is when you send it back to A. Events are the only thing you have to describe state. And maybe as a side effect, you also store some state as an optimization for querying. Hence CQRS. So let's dive into event-carried state transfer and how that impacts microservices. So what if we have, I'm sorry for the examples, what if we have an order service and there's another service that needs to know about order items? Of course, every microservices has its own database, and there's a way for those two services to communicate. Now, the order service will say, well, there's an order created, there's items added, items removed, order confirmed, etc. There's all sorts of events that describe what happened to an order. But the service on the right is not interested in all those details. It needs to know which items have been ordered. So now it needs to do the math of what does it mean to add and remove items, and then in relation to the order confirmed, because an item is only ordered if it was added, not removed, and then confirmed. Right. So there's a little bit of business logic in there. So what we need to do is copy that business logic that probably we know on the left, we now have to understand that on the right. And it's not only business logic, there's also language aspects involved. They probably use terminology in the left service that they don't quite use on this service on the right, etc., etc. So there's a lot of coupling. And I've seen worse systems where they say everything is an event. And this is literally the example that I saw. An order service receives an order, and it raises an event saying an order was created. The shipping service listens to that event, and says, I have confirmed the inventory. To which the order service responds by saying, okay, then I'm ready for payment. And the payment says, it's paid. Now I'm ready for shipping. The order is shipped. Now the style of communication here is really weird. And I imagine sitting at home on the couch, shouting through the house, oh dear, I have a taste for a beer, and just hoping somebody will arrive with a beer. I'm pretty sure that will not happen. I'm pretty sure my wife will not enjoy that form of communication. And she would probably go, oh, I so wish you went to the fridge yourself. Oh, that's another event, let me respond to that. It's a very weird way of communicating. And what's worse is that the dependencies are all over the place, in all directions. Because what an event does is just invert the dependency. It's not the sender that knows about the recipient anymore, it's now the recipient that knows the language of the sender. But if you do it two ways, and if you invert a bidirectional dependency, let's do some math. What happens when you invert a bidirectional dependency? Exactly. But then with weird communication, well, how is that for an improvement? Right, so that was lovely. And the problem is, events are not the only thing, right? We all know that there's also commands and queries. And unlike events, commands and queries have different ways of the dependency direction in commands, it's the direction of the command. In events, it's the opposite direction. So by using these commands, events, and queries, you can choose how you want your components to depend on each other, which is extremely important. So with bounded context as well, you want to be very careful with a bounded context, how it depends on other bounded contexts in terms of language. How do we adopt their language? Do we adopt their language at all, or do we prefer them to adopt ours, or etc.? So an event and a message is not the same thing, right? An event is a type of message. So if we were to implement this event-driven microservice in a slightly different way, the order service could now say, an order was confirmed. Oh, that's great, give me some details. Right? This is the process that Ben was referring to earlier, just notifying, hey, something happened that you might think is relevant. Oh yeah, it is relevant, right? Give me the details of that thing. And now I know that all the items, all the details in that order are items that have been ordered. That's a lot simpler, so we don't need to copy that logic. Now let's move to event sourcing. How does that change? Event sourcing is not about just emitting events. It's about ensuring that the stream of events is the truth, the whole truth, and nothing but the truth. How do you guarantee that all the events are really the source of truth in your system? Well, the only way to do that is make them the source of state for your system. Make sure that all decisions you make are based on the event stream, nothing else. If you generate them as a side effect, you might miss one. You might accidentally say something that you then roll back, or worse, the other way around. Or, well, not sure if that's worse, actually. So event sourcing helps you to make sure that your events are a reliable source of truth, and we do that by, instead of storing the current state, store everything that happened throughout the course of the system. Now, I already mentioned it before, when there's a number of technologies that associate themselves with event sourcing, and I don't want to start a blame game anywhere right now, but be very careful. When a system says, I can do this for you, it's not event sourcing. If they bring events from A to B, that's an event-driven system. It's an event bus implementation whatsoever. What makes event sourcing is when that system on the left uses the event it emitted to make the next decision. It only has the decisions it made in the past to decide on what the next decision should be. So if there's a rule that says you cannot confirm an order twice, it will not now know I should not allow that order to be confirmed because it was confirmed, because I can see that in my event stream. So instead of storing state, we now store history in that service database. Why would you want to use event sourcing? Well, there's a bunch of business reasons: auditing, compliance, transparency. So essentially, transparency is a form of auditing that you self-inflict. Right? You just want to be transparent about your decisions, either externally or internally. As you might have seen during one of the workshops, you can use it for data mining and analytics as well. There's a lot of value in those events in the past. But the value is a lot less if you can't ensure that it's a correct representation of what happened. And there's also a lot of technical reasons, actually. There's a lot of reasons why event sourcing makes certain things simpler. Right? So, well, you have a guaranteed completeness of your events, a single source of truth, but there's also nice ways to deal with concurrency in a system, because you know exactly what happened. So if you have a concurrent modification, You don't just know that something was changed, something happened in the meantime. You know exactly what happened in the meantime. So event sourcing is used a lot in occasionally connected applications, right? Applications that might go offline, that you expect to go offline and then come back online, and they need to resync their state. You can replay into new read models, debugging, right? You can see exactly what happened, etc., etc. But the last one is one I actually like. If you get the hang of event sourcing, modeling or implementing a model becomes a lot easier. Right? Describing something in terms of events and then commands and queries is very, very simple, and the audience you can share that information with is a lot larger than methods and if statements. But there are some challenges as well. The challenge of how do you deal with the increased storage size? Well, that problem's solved. I spoke about it this morning. We'll do that for you. But on the other hand, the storage size cannot be, well, in some environments it is a limiting factor because of extreme compliance rules, but in most environments, storage is so cheap nowadays that the value of the events in most cases is much higher than the cost of storage. It's really complex to implement. No, we've got Axon, so it's pretty simple. We need to implement in our brains event thinking, well, not only in our brains, in our organizations. And I think that is one of the open challenges that we still have. Right? How do you make sure that we think in terms of events when we see something happening? Is that an event, or is it a command, or is it, right? And to take that from a conversation between business people to the implementation, there's some challenges there. And I think there's a lot of people out there doing a good job, Alberto being one of them, but there's many people that are really stimulating this event thinking and showing what the power is of this event. So we event source all the things, right? If it's such a great thing to do, I think by now we understood that that is not what we should do. Be very careful with event sourcing. Although I do always say, some people say, well, should I use event sourcing for this or not? If you're not sure, do it. Because going from event sourcing to state storage is easy, trivial. Going from state storage, not having the past anymore, to event sourcing is impossible. Because all the information you had is gone. You threw it away. So try it. And it's in Axon, it's a couple of lines of configuration just to move from event sourcing to state storage. But event sourcing is really nice, but the application has to be built for it. And this, in different occasions, we've been talking about CQRS already. So we all know that CQRS is really nice in combination with event sourcing, because the command handler can now act on those events. It can read past events, make decisions based on the presence or absence of those events, make new decisions, report those decisions as new events, and then the queries can be executed against some projection of that event stream, a projection of all the decisions made in the past to provide information efficiently. So, again, we see caress all the things. Well, by now, I'm pretty sure you know I'm sarcastic. The problem is if you start building a system and then you have a working pattern, right? So, Ben, you've got your first few services up and running. Very happy about them. So let's do that pattern for everything, just like that. Let's evolve. You'll get something like that. It might turn into a mess. You have to be careful. Any form of communication that you have between components means that you have a contract. Some contracts are slightly more strict than others. But the problem with events is you publish them, but you don't know who's picking them up. So if you just publish them out in the open, you do not know who's picking them up. So you have a contract, a marriage, if you will, but you don't know who you're married to. You just know it's probably more than one. Well, that's pretty annoying. Think of the alimony in that case. Whoa. So you have to be very careful about these contracts. So you cannot just say, well, we just put this massive bus in the middle, and we dump all of our events on there, and whoever wants them takes them. Well, that's lovely. That means you now are married to whichever component decided that that was a useful event. If you change your event structure, you'll have some angry wives or husbands or, let's say, partners. That's not really what we want. And that's the concept of bounded context. Let's remove that, otherwise you'll start reading. And the idea of a bounded context is very powerful, and it took me a long time to have a feeling of understanding of the bounded context. And then you talk to Eric, and he starts asking people, what is a bounded context? Because I don't know. And we're like, oh dear. So is my understanding correct? And it's actually very difficult to explain what this bounded context really is. But to me, it's the boundary where certain words have certain meaning, where you assign meaning to specific concepts that you have. And other people might have a similar meaning, but maybe use different words. And also the meaning is slightly different. In every language, you have this word, and you translate it to another language. And if you understand both languages, sometimes but that word doesn't have the emotion that I'm trying to get across, right? Well, that is because they're different bounded contexts. And bounded context is a very important concept in microservices as well. So you don't want to just publish a message to everything. You want to publish a message to the other components within your context. The little group of components that really understand the emotion of all the words that you use, right? The meaning of the words that you use. And probably if the other services are interested, they're probably not interested in all the details, but in certain milestone events, right? Or what did you call them? Outside? Inside and outside. Outside events, right? That whole idea of inside and outside events is basically, these are the events, the inside events are ours. If you're in my context, I'll share them with you. If you're not, get out. So what you need to do is have multiple layers and say, well, I publish it to that bus, which then passes it to that service, and the other ones will read from the other bus. And you probably want, well, not probably, I'm pretty sure you definitely want, some form of anti-corruption layer. You don't want to just publish everything. You probably want to change your language slightly for the bigger public. So that anti-corruption layer will probably filter, it will probably translate, transform, and all the messages that are published on the top one to send them to the other applications. This is another diagram that you could draw. So you have these bounded contexts, and among each other, they share all the details because they understand what all the details mean. But across these bounded contexts, we want to be careful with what we share. Right? So in closing, whenever you build an event-driven system, consider the fact that you don't only have events, you also have commands and queries. You have sometimes intent to change something, you sometimes just have a need for information. How you implement those commands and queries? Well, if not Axon, it doesn't matter. Just make sure that you describe, okay, this is a query, and then think of how can we get that query across to the destination. They are as important as events in the design, but events need just a bit of that little extra because they are around for much longer than commands and queries. Once a command is executed, it's gone. Once an event is published and you use event sourcing, it will be there forever. That's a pretty long time. Sharing is caring. So if you share some information, if you share an event, you have to take care of it. You have to maintain that. You have to maintain the meaning of the event, the intent that it describes, and how you describe that may evolve over time, right? Have you ever looked at code you wrote half a year ago? Imagine looking at an event you put in the event store half a year ago, or 5 years ago. So make sure that you have a way to evolve how these events or how these messages are represented. Beware of coupling across bounded contexts, right? So every form of coupling should be, at least in some architectural discussion, you should be aware of which way are we making dependencies. Microservices is a journey, right? It's not a destination. It's definitely not a quick taxi ride just to get there, right? It's a very long journey that you have to take one step at a time. Build yourself a monolith first. Make sure you have this discipline to build that monolith first, right? So wax on, wax off. And I'm pretty sure in that movie that this was not a coincidence. With that, I'd like to thank you for being here today. I hope you had a good time. And I hope my subliminal messaging will stick for the drinks that we have right now and the weekend thereafter. I fear that some of you might stay in Amsterdam for the weekend. I wish you the best of luck. I really hope to see you again next year or before. Thank you.